I'd like to talk a little bit about cloud computing in general, and there are some economics that are going on with Canary that I think will help, and economics throughout the higher education system in Canada, that I think will help in terms of growing the cloud and making the cloud more viable in Canada. So if we look at Canary, the first point here, Canary addresses a market gap. Right? So it provides a kind of network service that the big players like Bell and TELUS simply aren't interested in getting involved in. This is not a place where they want to build a network. So Canary exists because we fill that market gap. Okay? Canary also aggregates demand. So we make that market gap economically viable by bringing in a user community from across Canada of researchers and educators. And then finally, Canary facilitates regional parity. So Canary allows folks in Memorial University to have access to the same facilities as folks at the U of T. Right? So there's three key economic reasons for the existence of Canary. And from a cloud perspective, the notion that we're addressing a market gap means that we're lowering costs for folks. So that means we're lowering costs for access to the cloud. One of the big challenges for researchers is that Amazon may be cheap, but getting to Amazon with large data volumes isn't cheap. So Canary can help facilitate that. It can facilitate a lower cost access to the network. In terms of aggregating demand, we can become a collection point to help bring all of these users together to use the cloud service. And finally, with regional parity, we can make a cloud service available to everyone in Canada on a shared basis, on an equal basis. So let's look at the notion of a shared service provider. And so if a cloud service is a shared service, then one of our big constituents at Canary is the university IT organizations. They're all very different. They're like snowflakes. They have different degrees of centralization versus decentralization. They have different mandates. They have different funding models and so on. They're all very, very different. But the only thing they truly share is the network. Right? So the network becomes something that you can leverage to make shared services more viable. It truly is in and of itself a shared service, which helps us move us along the road towards a cloud service. Another thing that's going on in Canada is dramatic growth in research data. Okay, so we're seeing the humanities and social sciences, and I don't mean to insult anybody in the humanities and social sciences, but they are discovering computing in a new way. They're doing dramatic things with videos, with graphics, with images, and it's an explosive use of data for those folks. Medical and health sciences, we're seeing huge growth in 3D imaging and real-time diagnostics and real-time learning using the network. Traditional sciences and engineering are continuing to grow. Things like the square kilometer array are generating volumes of data that we could never have predicted just a few years ago. And then there's just the data management issues within research, backup, restore, and the notion of archiving and protecting research so that it can be recreated 10 years from now. So Canary can help support that. What we're seeing with this data growth is increased demand on computing cycles, on network capabilities, and on data storage. And all of these can help or can be solved with better cloud services in the future. So let's look at that impact on research computing. So why are we running high-performance computing on campus? I believe there's 27 high-performance computing data centers on campuses. That's a large number for a country like Canada, so there should be some rationalization. I think Jonathan's in the room, so you would at least agree with that. So we need to think about how we rationalize those data centers, and if it goes from 27 to 2, 3, 4 data centers, we're really going to need the network, right? And we're really going to need cloud services to make that viable. Now, if 80% of the research computing isn't high-performance computing, and that number is debatable, but there have been some studies that have suggested that, that means there's a lot of computing going on in research in Canada that could fit on a cloud service, could naturally belong on a cloud service, but right now is scattered across all of Canada. So that brings up a couple of issues, and one is, for the most part, despite DARE and despite other efforts, the cloud really isn't in Canada, and that's a direct quote from Mark. I stole that from you, Mark. If it's not in Canada, that starts to drive protection of privacy issues, freedom of information requests, and issues around those, some of the things that Michael Geist talked about this morning. and also national competitiveness. So we need to think very carefully if we're going to support high-performance computing and increased research computing in Canada, how we can build Canadian cloud services. Another interesting thing that CANARIE does is the Canadian Access Federation, well, CANARIE and CUCIO. Two key features there are Eduroam and Shibboleth, and there are some things we can do to leverage those services. But ultimately, the point is that in a cloud environment, Canadian Access Federation can use authentication credentials from your local environment to allow you access to those cloud services anywhere in Canada. I'm running out of time, so I'm going to go a little bit more quickly. So Canada, the world's data center. This is an interesting concept. So what's unique about Canada? First of all, we have huge renewable hydroelectric resources. We have a lot of renewable energy that's available in Canada in various places. The farther north you go, the cooler it gets. So you don't spend as much money cooling your data centers, right? It's somebody nodding his head. You must be from Edmonton. And we also have the Green Star Network. So CANARIE has invested heavily in the Green Star Network, and this is a pilot, but it has proven that we can run production services across multiple nodes, not only in Canada, in the world, following the wind and following the sun. I didn't think it was possible when I first heard it, but we ran our annual general meeting for CANARIE on this network, and when it got cloudy in Montreal, the services automatically moved to Calgary, where it was sunny and windy. And then finally, what can we do about taking advantage of this huge backbone we've got called the CANARIE Network? And the final point I want to make here is that manufacturing is the new agriculture. Right? What I mean by that is that those huge numbers of manufacturing jobs in Ontario, they're at risk. Those folks that are in the auto industry, those jobs are at risk. So Canada has to look for new industries, new economies. And so we need to think about things like DARE and how DARE can start to bring us into the new cloud world. And I just want to, again, mention the partners here, Cybera, University of Alberta, University of Sherbrooke, and CANARIE, and that we do have 23 SMEs and we're growing. So the DARE pilot is an example of that, that success we can have with cloud computing in Canada. And so 1 minute and 16 seconds left on my last slide. We do have a cloudy future, but a cloudy future is a good thing. There are 6 drivers in Canada that I think can make cloud computing a very viable activity in this country. And a very viable business model. So it comes back down to economics. I think we can do this in an economical way that will help improve productivity and make Canada a better place for Canadians. Thank you.